Good morning, my students. Today we are going to demonstrate to you experiment 5, that is aldol condensation, where we are going to synthesize 1,5-diphenyl 1,4-pentadiene 3-one, in which the synthesized compound will have the 2 double bonds and a ketonic group. The apparatus that we are going to use here today is the conical flask, the beaker, the dropper, the measuring cylinder, the filter paper, hot plate, and this is the filtration apparatus. The chemicals that we are going to use for this experiment, most important is benzaldehyde and acetone, and these are the solvents. Like you can see, this is ethanol, ethyl acetate, and sodium hydroxide, which is going to help us in hydrolysis. The reaction is mostly between the benzaldehyde and the acetone, which leads to the formation of the CC bond between the two compounds. Okay, now I'm coming to the procedure. This is my first step where I'm taking a 100 ml conical flask and I'm going to add 15 ml of sodium hydroxide. So this is my sodium hydroxide. I'm going to take 15 ml and I'm going to add into this, followed by 15 ml of ethanol. So that is 95% of ethanol. So again, I'm going to add 15 ml. The next step which I have is add about 1.6 grams of acetone, which is given in your procedure. But my students, this is in the liquid state, so you need to convert it to ml, and it'll come around roughly 2 ml of acetone. So 2 ml of acetone. Again, benzaldehyde, which is again considered to be in the solid, also in the liquid state. It's highly corrosive, and I'm going to take around 5.6 ml of benzaldehyde. In your procedure, it's given us 5.83. So we're going to convert it to ml using the density. I have to quickly transfer this because it turns into a solid. The ratio between acetone and benzaldehyde should be very important. This is around 2 ml and this is around 5 ml, which I have added as you can see here. I see, sir. Okay, this is step 3. After mixing all the chemicals that are required, we just stir it under the hot plate using the magnetic stirrer, and the stirring should be for 15 minutes. And after 15 minutes, we are going to cool it under ice bath. As you can see here, there's a formation of thick yellow precipitate. So we leave it under ice maybe for around 5 minutes. And after that, we take it for filtration. As you can see, the filtration apparatus. So we filter it. So after transferring the whole precipitate, we wash the precipitate with 95% ethanol, that is cold ethanol. We don't use any diluted distilled water. We use cold ethanol for filtration. Okay, this is my last step that is going to deal with recrystallization. This is the filtered crude product of the aldol, which we are planning to synthesize. So crude product, as you know, it contains many other impurities and unreacted reagents. So we need to remove them. So this is the last step. So in this, we need to add around 20 ml of ethyl acetate. So I'm adding 20 ml of ethyl acetate into the crude product, and I'm going to keep it on a low heat. On a low heat and I'm going to stir this, maybe using a glass rod, till the entire thing dissolves. So as you can see, the whole thing is getting dissolved. To this I have to add 10 ml of ethanol. So now you can see the whole thing has dissolved. To this I will be adding 10 ml of ethanol. Yes. To this I add 10 ml of ethanol, and I keep stirring it till the whole thing gets dissolved and it becomes a very clear solution and it starts boiling. So now as you can see, it is going to completely boil, and after that we switch off and we cool it under ice bath so that it gets recrystallized and we get the pure product. Taking it out, yeah? Okay, this is the final pure compound where you can see the crystals are of the synthesized pure compound is present inside the beaker. We need to filter this, and after filtration we need to dry this compound and then go for the final weighing of the product. I'm coming to the last step of recrystallization where I've finished, and I'm doing the filtration of the pure product. And you can do washing with ice cold water.